that this side we have something which is propyl, this other side we have something which is tert-butyl. So you can just come and look if you have an option. Look here, propyl and tert-butyl. That's the only option. It was only option B. You can't have methyl coming to give you that on an ether. Remember, on an ether, they're just connected by an oxygen, just like single like that. So there had to be something which was propyl. Okay, now remember that here they're saying propyl bromide. Propyl bromide, in other words, you had this as your halogenoalkane, which is the alkyl halide, right? Which you add to the of course, you started with it as an alcohol, but the alcohol is converted to an alkoxide first. You add an Na to convert it to an alkoxide, because we've never seen in alcohols, we didn't see any time when we had an alcohol react with a halogenoalkane. That never happened. Alcohol halide doesn't react with an alcohol itself. You need to convert it to an alkoxide first. So that's what happens. Then you can be able to do that. So here, our alkoxide, remember, it'll be like O minus Na plus, like that, okay, with your alcohol here, blah, 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 right? So that is what we had. Now, anyway, so here we had tert-butyl and propyl, yes, and they can give you propyl tert-butyl. So it works. That is fine. Now we can go to number 6. So this is the only answer, because this one was methyl and prop, no way. This was methyl and prop, no way to give me those two. Methyl and what the heck? I mean, this doesn't even make sense. It has to be one propyl and another tert-butyl, then they come together, then we can get. So now we are at number 6 now, okay? So now what is number 6 saying? Number 6 saying the Williamson synthesis. Williamson synthesis, really? What do we have? Williamson synthesis, no aldehyde. How do we have that? Alkoxide and a metal? No. Alkoxide is what we get when we react an alcohol with a metal, okay? They say complete the following sentences. The Williamson ether synthesis produces ethers by reacting what? It's unsymmetrical ethers, yes. Symmetrical ethers are made by the alcohol sulfuric acid method, where you add sulfuric acid and you use 413 kelvins, all right? So anyway, to your alcohol, we know that if you use 180 degrees Celsius, which is 453 kelvins, this will lead you, 180 is like 453.15, which will round off to 453 kelvins. This will give you an alkene. Okay, but if you heat to 413, not 453, but 413 kelvins, which is not 180 degrees, 413 kelvins, then you are going to get your ether, but a symmetrical one. Unsymmetrical one, yes, you're going to have to do, yes, alkoxide and alkyl halide, which is, remember that it's the halogenoalkane and alkoxide, right? You can't have alkoxide and metal. No, you can't have alcohol and metal. They give you alkoxide, but you then need to mix it with the alkyl halide to get the ether. So this is the only feasible answer, okay? If they had said alkyl halide and alcohol, it still works, but you know that the alcohol, you need to add a metal first, and then it becomes an alkoxide, then it meets with this, okay? Anyway, this is the other question on alcohols, right? Now we can go to the other ones in section B. Goodbye for now. We'll do it in the next one.